Hello guys and welcome back to Leet Logics. This is the maximum element after decreasing and rearranging. It is a lead code medium and the number for this is 1846. So in this problem, we are given with an array of positive integers ARR and we have to perform some operations, possibly some operations, and these satisfy some condition. The conditions are as follows: that the value of the first element in the AR should be 1, and the absolute difference between any two adjacent elements must be less than or equal to 1. That means ABS, mat.abs, ARR of I minus ARR of I minus 1 should be always less than or equal to 1. And for this we can perform two operations. Either we can take decrease any element to a smaller positive integer, or we rearrange the elements of the array. So to maximize the largest element in the array under given conditions, we need to ensure that the array is rearranged and the elements are decremented strategically. So the goal is to have a sorted and incremented array that satisfies the condition. So I have seen the solutions here given in this solution panel, and everybody is using a sort function. Yeah, like you can see, everybody here is using the sort function, which is not like uh, suggested to use in an interview. Instead, you should use extra space, but you should not use the inbuilt functions. So I am going to tell you a code with only basic for loops and array, but no sorting function. So let's see. For that, we'll need an counter array to count the occurrences of each value from limit uh, -1 till limit -1, that is the length, and we'll iterate through the input array and update the counter every time. And then we'll have something like a variable to store the answer, and then we'll again iterate through the counter array and then again update the answer. You can see we have a counter array. So this counter array is actually initialized by taking the value like ARR of I minus 1 or L minus 1, whichever is minimum, that is taken into the counter array, and afterwards we are iterating through the counter array and updating the answer. You can see we are iterating through the array, rearranging the elements, and we are then updating the max value. So in this way we can get the solution. Let's try to code it, but before that, please do like the video, please subscribe to the channel if you are new to the channel, and share it with your friends. So initially we'll need the length. This will act as the limit, and we have a counter array equal to new int now. As I told you, you have to iterate through the array and initialize it with counter of mat dot minimum, whichever is minimum, ARR of I minus 1 comma L minus 1. So this is the equation, and you have to do a +1 in this, so let's do a plus here. So this was this, like initialization. This step was this: ARR of I minus 1 and L minus 1 of counter is incremented. Otherwise we are going to define a variable answer, iterate through the counter array. Now since the first element is always has to be 1, so we are starting with 1. And in this, simply update the mat dot minimum, take either I plus 1 or take answer plus counter of I and simply return the answer. So let's see. So sample test cases are passed. Let's try to submit it. You can see the solution is accepted. It has a good time complexity but not a good space complexity. It is because we are using a counter array. You can do it by using the inbuilt sort function, but in an interview it is not suggested to use that. So let's come to the time complexity and the space complexity. So the time complexity of this solution is O of n, and the space complexity is also O of n, because we are taking additional counter array of size n, so that's why it is O of n, and the time complexity is O of n because we are iterating through the input array once to update the counter array and then iterating through the counter array itself, so it is O of 1. So this was my solution for today's problem. I hope you got the logic. Please do like the video, subscribe to the channel, and thank you for watching the video. Have a nice day.